Thank you for the introduction and pleasure to be here. Yeah, welcome to my talk about an evidence-based quantum approach to consciousness. Well, this is biophysics, first of all. The agenda of the talk is as follows. To begin with, we will take a look at the neurophysiological correlates. So we start really from evidence. Then we will embark on a journey that aims to unveil the fundamental principle underlying conscious processes. And finally, my goal is to be, based on these principles, to shed new light on the formation of conscious states and possibly also on the nature of consciousness. So let's start with the neurophysiological characteristics of consciousness. We know from many pieces of evidence that conscious states are closely linked to long-range synchronized brain activity in some frequency bands, beta, gamma. And in-depth analyses of the data really suggest that these synchronized activity patterns result from phase transitions and represent the collective behavior of large numbers of neurons. We also know that pattern formation in the brain exhibits long-range correlations and robust features of criticality. And we also know that under certain circumstances, for instance, under anesthetics which induce unconsciousness, brain dynamics deviate from criticality, implying that obviously criticality is a requirement for the emergence of conscious states. And viewed from a different perspective, one finds that large-scale activity patterns arise from neuronal avalanches, which have also been shown to bear the hallmarks of criticality. So, taking all these pieces of evidence together suggests that the conscious brain operates in the critical regime, and this operating principle is known as self-organized criticality, which, now in explicit terms, means a system's ability to adjust a control parameter that keeps the system in the vicinity of a critical point of a phase transition. And we know even more, namely, that in the brain this critical control, this key control parameter, appears to be the excitatory-inhibitory balance, meaning that critical brain dynamics relies on firing rate homeostasis. So the picture looks basically like this. The homeostatic regulation of the firing rate takes place in local networks, leads to local balance and local synchrony, and neuronal avalanches and finally large-scale synchronized activity patterns result from the controlled propagation of locally synchronized action potentials. So this is a kind of orchestration, a concert taking place in the brain. And these findings now fuel the expectation that insight into the mechanism behind critical brain dynamics, or more specifically, insight into the mechanism behind firing rate homeostasis, will lead us to a deeper understanding of the fundamental principle behind the formation of conscious states. And when you are a physicist, and you look at this immediately leads you to quantum field theory, because it is quantum field theory that provides us with the appropriate methodological resources for explaining phase transitions and understanding long-range correlations and collective behavior in many body systems. And this is what I call an evidence-based quantum approach to consciousness, because first of all, and that's important, it relies on empirical evidence. Evidence from the empirical evidence indicates that conscious processes are based on self-organized criticality. And second, a deep understanding of self-organized criticality requires a framework of quantum field theory. So this is a natural approach to go ahead. So let's then try to find out and embark on a journey that aims to unveil this fundamental principle. And for this purpose, it's good to start with the architecture of the brain and the organization of the cortex. From, again, empirical evidence, we know that the cortex can be viewed as a modular system whose basic functional unit is a so-called cortical microcolumn. And such a microcolumn consists of roughly 80 to 100 neurons, most of which are pyramidal neurons. The remaining neurons are inhibitory interneurons, which kind of regulate the activity of the pyramidal neurons. And going one step further, we have the presynaptic and the postsynaptic terminal, which then leads to a cascade of activities, but I do not want to go into all the details here. The main or the key message on this slide is that the cortex consists of a vast number of these cortical microcolumns with a typical diameter of 30 micrometers. In the next step, we take a closer look at the structure of such a microcolumn. And such a microcolumn receives numerous inputs from other cortical areas and the thalamus, and these cortical and thalamocortical fibers, they connect to the synapses that populate the dendritic trees. And in active synapses, signal transduction takes place through the release of neurotransmitters, mainly excitatory through glutamate. The peak concentration of glutamate can be found in synaptic vesicles, and there is also an enormous tissue concentration in the brain of glutamate, which is regulated by certain processes, which I will also not go to explain here. But the message here is there is a huge pool of glutamate in a microcolumn, and this glutamate pool forms a kind of glutamate water matrix. I think it's important to note here that glutamate and water are the two most abundant molecular components in neural tissue. And so from a physical perspective, a microcolumn is a bundle of neurons integrated into a glutamate water matrix. Based on this model of a microcolumn, we bring now quantum electrodynamics into play. Quantum electrodynamics, or QED, is the fundamental theory of the electromagnetic interaction, and that's now the important point, according to QED, the vacuum, rather than being a void or an empty space, is pervaded by a fluctuating ocean of energy. So there is always a ubiquitous background field of energy in the universe. And one constituent of this ocean is the so-called zero-point field, the electromagnetic zero-point field, which consists of a spectrum of normal modes, which are, so to speak, the elementary frequency components of this ubiquitous field. And according to QED, it's now this background, this zero-point field, which is the ultimate basis of the electromagnetic interaction. Now one can achieve a QED-based description of a microcolumn, going back to neuroscience, which is based on the resonant interaction between the zero-point field and the glutamate water matrix. And this description, which can be really clearly formalized, leads to equations expressing the interplay, the dynamical evolution of this coupled system. And one important finding now is that upon exceeding a critical glutamate concentration, this coupled system undergoes a phase transition which is prompted by a resonance phenomenon. And this resonance phenomenon can be studied in mathematical detail, which I will also not going to present, but the main finding is that the functional principle of a microcolumn is based on a three-stage process. In the first stage, a phase transition is initiated by resonant glutamate zero-point field interaction. And this interaction is actually triggered in the synaptic vesicles in which the glutamate concentration reaches its peak value. Basically, the computations clearly indicate that this peak value, which can be empirically measured, lies exactly at the critical threshold required to set off the resonance phenomenon. And now this resonant glutamate zero-point field interaction has which leads to the ignition of a microcolumn, has two very important consequences. On the one hand, on the part of the glutamate pool, this resonant interaction leads to the emergence of a macroscopic quantum state in which all the glutamate molecules exist in a superposition of a ground state and a vibrational excitation. And on the other hand, on the part of the field, this resonant interaction leads to a boost of the dominant, the dynamically relevant field modes that play with the glutamate pool. So we have an effect on both sides. The emergence of a macroscopic quantum state in the glutamate pool, in the microcolumn, and the amplification of field modes, the selective amplification of field modes. And this selective amplification is now important for the second stage, because this triggers an avalanche process in a microcolumn that drives the entire glutamate pool to a macroscopic quantum state. And the transition to this stationary state results in the formation of a so-called coherence domain, which can now be calculated and amounts to 30 micrometers, which is in excellent agreement with the empirically verified width of a microcolumn. And now there is one important consequence of such a coherence domain, in which all these glutamate molecules reside in a quantum superposition, namely that such a state is dynamically favored and leads to a substantial energy gap that inhibits rapid decoherence. So a formed coherence domain is protected from decoherence because of this energy gap. And there is another effect which is very important, namely the formation of such a coherence domain entails a frequency shift of the dominant, the dynamically relevant field modes from the terahertz to the microwave region, so that we can say that a phase transition culminates in the generation of an intracolumnar microwave field. So this is the consequence of the phase transition. So it builds up its own field, and that's now the interesting point, which is relevant on a larger scale and leads to effects, to neurophysiological effects on a larger space scale. Since both theoretical calculations and empirical studies demonstrate that exactly microwaves are relevant, and they strongly influence the flow of ions through voltage-gated ion channels. And this suggests that this phase transition-induced field, the microwave field, obviously is now important, or assumes a control function, an important control function on this scale within a microcolumn concerning firing rate homeostasis. So in detail, the field that can be shown activates voltage-gated ion channels, increases the excitability of the neurons, shapes the waveform, and leads to the regulation of the firing rate. And coming back to what I mentioned earlier, this firing rate homeostasis, this regulation is now the key point to explain the basics for critical dynamics. So taking all these pieces together leads to a very clear picture, namely to the conclusion that self-organized criticality, the key feature of a conscious system or a conscious process in the brain, arises from a bottom-up orchestration process driven by the zero-point field. And this process starts with the resonant glutamate, so it's here the resonant glutamate zero-point field interaction, which triggers a phase transition. The byproduct, first of all, is the amplification of the dominant field modes, which drives this game. Upon exceeding a stationary state, these field modes build up the intracolumnar microwave field. This field regulates the firing rate locally, which then, as an outcome, leads to the controlled propagation of locally synchronized action potentials. And this is the basis for the formation of large-scale activity patterns, which bear the hallmarks of critical dynamics. And from this picture, profound new insights take shape, namely that the zero-point field is instrumental in orchestrating activity patterns that are associated with conscious states. And the fundamental principle behind the formation of conscious states seems to be the resonant coupling of the brain to the zero-point field. And the necessary condition for the formation of conscious states is the selective amplification of field modes. So, in essence, there is no consciousness without the zero-point field, and there is no formation of concrete or differentiated conscious states without the brain's indirection resonant coupling to the zero-point field. So, this is physics. I briefly, and that's a well-defined way of going forward. It's a physical theory about physical processes taking place in the physical brain under conscious conditions. And the key ingredient is also a physical field, first of all, namely here, the zero-point field, which has a spectrum of normal modes. Each normal mode is associated with a specific frequency, and we are talking here about a formless ocean of energy. How does that help, or could that help us to learn something about the nature of consciousness? And for this purpose, I made now exactly one hypothesis. I postulate that in reality, this field may be more than just this energy field. And I speculate that this field is actually a dual aspect field with a physical manifestation and a phenomenal asset. So under this view, we are not only talking about normal modes with a specific frequency, but also about normal modes with an inherently phenomenal quality. And from this perspective, this is not only an undifferentiated ocean of energy, but at the same time an undifferentiated ocean of consciousness. So in this approach, I take consciousness to be ontologically fundamental, and I postulate that the zero-point field is a candidate for the fundamental psychophysical backbone of the universe. And now from this perspective, we can revisit this resonant brain zero-point field coupling. So from the physical perspective, well, this leads to the selective amplification of field modes, which is ends up with a set of amplified normal modes. But from the phenomenal perspective, this can be interpreted as the excitation of a set of specific phenomenal qualities inherent in the field. And this is, in a way, a mechanism to form a unified conscious state. And when you only look at the brain, you do not take anything above into account. What you see is just a neurophysiological correlate of consciousness, which manifests itself in the formation of a coherent large-scale activity pattern. But the important point is above, namely the resonant interaction with the field. So let me come to the last slide and the conclusions, which I tried to condense into 5 key take-home statements. Number 1, that's physics. An evidence-based quantum approach indicates that the fundamental principle behind the formation of conscious states is a resonant coupling of the brain to the zero-point field. And this coupling causes an amplification of the dynamically relevant modes in this field, suggesting that the necessary condition for the emergence of conscious states is a selective excitation of field modes. So this is still physics. Now, this is speculative. I think these insights support the hypothesis that it's not the brain that may be the most important thing to study, but the zero-point field, and that this may be the key to the understanding of consciousness, and may act as a universal, inherently sentient, undifferentiated background field of consciousness. And actually this approach unfolds enormous explanatory power because it explains how differentiated conscious states arise from an undifferentiated background field through selective excitation of phenomenal qualities, without having the need to explain the existence of consciousness in the first place. So it's there. So metaphorically speaking, the keyboard of consciousness is the zero-point field. This is a universal keyboard of consciousness. The brain does not produce consciousness as such. It produces differentiated states of consciousness by playing chords on the field. So this is now, I think, a very clear perspective that comes out of this approach. So thank you very much for listening. So this would be the essence of a evidence-based quantum field theoretical approach to consciousness.